It's a pleasure and an honor to receive the Ramón Margalef Award, and especially this year when my postdoc mentor, Daniel Schindler, is recognized with the Hutchinson Award. So I went to University of Washington as a postdoc to work with Daniel, and I had a National Science Foundation bioinformatics postdoc. And it was really an opportunity for me to learn how to work with long-term ecological data, working on the Lake Washington plankton data set, and to gain these new skills. It was an experience that truly set me on my present path. I joined Daniel's lab at a time that it had rapidly grown into quite a large group. It was a really rich experience that not only in terms of the science, but also in introducing me to creative colleagues who became longtime collaborators and really dear friends like Mark Sherrill and Jennifer Sherrill. Having gained that experience with time series analysis working on Lake Washington, I was unexpectedly quite lucky to get a phone call from Marianne Moore near the end of my postdoc. So Marianne had just returned from her regular trips to Lake Baikal in Siberia. And she had learned of a 60-year Russian data set, and knowing of my expertise, she sought advice and ultimately collaboration. I want to mention before moving on that in the corner of your screen, you're going to notice some QR codes. And that's one of the things I like about virtual conferences, is that you're sitting close enough to this presentation that you can use your camera on your phone or your tablet to quickly pull up any of the manuscripts or articles that I might be talking about. So I think it's fair to say that nobody in the West would likely know about the long-term Lake Baikal data set except for Marianne. So she had taken her students to the lake every several years, and they invited Siberian scientists to meet with the students. And one year, a scientist mentioned a 60-year data set, and Marianne thought it was just a translation error until a few years later when it came up again. And she came back to the US and we got to work. I've always thought of Lake Baikal as the holy grail of limnology. It's a lake of superlatives. It's the largest by volume, it's the oldest, it's the most biodiverse, it has the highest levels of endemism. And I've never taken for granted the opportunity that Marianne gave to me when she contacted me. And I never imagined I'd be so lucky to still be working with Russian and American collaborators on this magnificent ecosystem 15 or so years later. So our colleague Lyubov Izmestcheva emphasized to us when we first started out that the long-term warming trend would be the most prominent trend in the data set and potentially the most important in terms of its effects on ecosystem processes and on organisms. And indeed, we found that the warming of Lake Baikal has been very rapid. It's been twice the rate of the annual air temperature warming for the same time period. So why so fast? Probably because ice is getting shorter. So a conservative estimate would be that it's 19 days shorter over the past century. Well, this work we published on Baikal joined a larger body of literature from other lakes around the world showing trends in warming and in ice loss. And individually, many of us have demonstrated these types of patterns, but had not yet done a synthesis of that work at a larger scale. So the Global Lake Temperature Collaboration sought to change that, to bring together not only in situ researchers who have long-term data, but also folks who work with satellite data products that estimate lake temperature. And that type of synthesis was especially important because the satellite data are powerful in allowing us to see lakes that are remote or otherwise inaccessible, while the in situ data provide deeper and well-grounded understanding of specific ecosystems, many of which are too small for the satellites currently to see. We were able to do the first comprehensive study of lakes warming worldwide. And that collaboration brought together a core team of people with whom I've collaborated a great deal since the time of that work. So Sapna Sharma, Catherine O'Reilly, Jordan Reed, and several others. that work really became the springboard for other large collaborations. So for example, we saw in that study that some of the highest rates of warming were on those lakes that typically experience winter ice, highlighting the idea that the loss of ice in seasonally covered systems was really key. And it encouraged us to consider what we might know about winter limnology based on the data at hand. Sapna Sharma led an important synthesis showing not only the extent of the present ice loss, but also projections of ice loss to be expected in lakes worldwide based on synthesizing lake data with climate modeling data and showing the loss of ice from thousands of lakes under the most likely scenarios of climate change. So we can clearly see the urgency to trying to understand what processes are changing for lakes as ice is receding worldwide. But truthfully, we've never had that much data from the winter. It's dangerous and logistically difficult to work in winter, so limnologists historically have not had that much experience with winter. We made an open call through listservs and through our professional networks to see who might like to get together to put together what data we could find from lakes around the world and to see how biologically active they are under the ice. And the response really was overwhelming. We had originally thought to bring together traditional workshop of 20 to 25 people, but we received over 160 responses from people who wanted to do this work with us. So we had to stop and take a step back to figure out how to organize ourselves and allow this level of participation that people were so clearly hungry for. So I leaned heavily on Aaron Galloway and Steve Powers, who did postdocs with me, as well as my data managers, Kara Wu and Steph LeBou. And my research group has included this position of data manager for over 10 years. I find that these professionals have been pivotal for my work by managing data, by creating base R code for analyses and data wrangling for me. It's the difference between me participating in some research projects or not, particularly as my administrative responsibilities have grown over time in my professional roles. So I'm mentioning it here because I think many of us are learning that we need a little restructuring of the traditional lab group so that our postdocs and our grad students and we can focus on limnology rather than spending all of our time data wrangling. And we can provide career pathways that give advancement in data science. So Kara went on to be a successful bioinformatics engineer, and Steph is a data librarian at UC San Diego. Actually, Steve now is on faculty at Baylor University, and Aaron is on faculty at Oregon Institute for Marine Biology. They were all crucial in figuring out how we could crunch these data when so many people wanted to participate. So ultimately, a group of 65 researchers were willing and able to provide their data. And we synthesized data for 100 lakes, finding that winter has substantial biological activity under ice. So for example, here we're looking at chlorophyll as a proxy for biomass of algae under ice, and we see that it can be close to half that of summer, which is a lot more than we previously thought. And it sometimes exceeds that of summer, especially in lakes that have very clear ice that allows a lot of light to reach the water under the ice, like Lake Baikal. So the downside of this finding is that we now know that we don't have any good excuses for taking the winter off from fieldwork. So to me, this has been a great example of using data synthesis to ask what we can know given the data in hand in a data poor situation where there's some urgency, like the rapid loss of ice, so that we can tighten up our questions for targeted future work. And perhaps more importantly, I see how I and my fellow leaders of these and other syntheses have provided our early career colleagues opportunities not only to engage in the science in these collaborations, but also to learn the skills and get the experience for leading collaborations of their own in the future. So Ted Ozerski came to our Lake Baikal project as a postdoc. And in addition to his skillful and creative lab and field work that he did on Baikal, he became a critical collaborator on several large data and literature syntheses that I led. And he's now on faculty at University of Minnesota, Duluth. And among other things, he's now leading a large collaboration to synthesize winter limnology on the Laurentian Great Lakes. Allie Kramer was a PhD student at Washington State University, and she has formidable skills in quantitative marine ecology. And she also saw a need among people using R as a programming language at the university, a real need to come together as communities. So she started an R users group as a grassroots sort of activity, bringing together scientists and engineers and sharing tips and tricks and being available to each other to answer questions. And before taking her postdoc at UC Santa Cruz, she even developed her succession plan for the R users group with my current data manager, Matt Brussel, and my grad student, Michael Meyer, taking over. So both Matt and Michael came in with strong backgrounds in ecology and learned from working on my varied collaborative syntheses the skills that are needed to run big collaborations, not only the quantitative and computational skills for big data synthesis, but also the work we have to put into making the interactions with people really vibrant and productive, and to manage the interpersonal conflict that inevitably will arise over long time periods in a large, diverse group. These skills are underpinnings for data-intensive science and ultimately the move toward open science. And a great example of early career ecologists moving towards open science is this massive data set that this group generated using public data. They aggregated it in a way that other limnologists will be able to use without having to have specialized data skills or access to high performance computing. So they published the data set, they published the code, it's all open and available, and they are really walking the walk on open science. And I know that we all have enjoyed the surprise of seeing people we mentor take the lessons one step beyond the expected. So when all of the aquatic conferences were canceled this year due to the pandemic, my grad student Michael and postdoc Jake Swart at the USGS decided to convene a virtual summit for aquatic science focused on open science and data science. They had over 425 people register, and they wrote up their experience in a recent LNO bulletin piece so that others can learn from it. So, and it's open access, of course. So for those of you hoping to find out more about these skills, I hope that this paper is a good starting place. I worked with longtime collaborators Matt Jones and Mark Schildauer and an amazing cast of superstars to summarize the data skills and collaboration skills with which we all need to be familiar in order to scale up our science. Much of the collaborative work I've mentioned began with small amounts of workshop funding from NSF and NASA, and it's now sustained by the Global Lake Ecological Observatory Network. GLEON is a grassroots network of lake researchers who are highly motivated to collaborate and to be inclusive. It's been a great way to keep promoting winter limnology while not having to shoulder all of the responsibility of coordination ourselves. So I'd encourage you to check it out if you haven't already. At this point, my WSU lab group is a pretty small group, but we never feel that way because all of our projects involve a dozen or dozens of collaborators. And I really can't imagine having so much fun and so much productivity in any other way. So I'll close with a joyful photo. Jumping into the 6-degree water of Lake Baikal is a young person's game, even at the height of summer. I am not shown in this photo. But this photo always brings a smile to my face as I think about my early career colleagues and the waters that they fearlessly jump into as they move forward in their careers.